Good morning, everyone. Thank you all for joining me for this talk about archiving and accessibility with iText. I'm Raf Hens from iText software. Bruno already mentioned 2 times today that we would do a duo presentation, Alexander and I, but because of possible practical problems, we intended to do some live demos. We decided to just put everything as screenshots into the slides to avoid Murphy's Law. But if I run into any technical issues or problems with the demos, I'm sure Alexander will come to my rescue to aid me. So we're going to talk about PDF-A, more in detail, PDF-A 3A, level A, and PDF-UA done with iText. So if we talk about PDF-A, we're actually talking about the ISO 19005 standard, and for PDF-UA we're talking about ISO 14289 standard. But I won't go into details about everything in the standards. Instead, I will show some highlights and show you with iText code samples how you can achieve compliance with those standards using an iText implementation. So important for people not very familiar with the standards, it's important to know that these are not new technologies, they're just based on regular PDF, so ISO 32000, but they impose restriction and they define requirements how to use PDF to get documents that are suited for archiving and for accessibility. So a quick overview of the structure of this presentation. First, very simple, we will create a PDF document, let's say a regular PDF document. I assume this is not new for anyone here, creating simple PDF documents. Then we will go from this simple PDF document and add tagging, tagged PDF, to get to tagged PDF, so introduce structure into the PDF. Then we will go from tagged PDF to PDF-UA, adding proper metadata, font embedding, alt text for images. Those are the highlights I want to show you in iText code. Going back to PDF, we will do the same for PDF-A 3 level B, conformance level B. So B is commonly referred to as the basic level, which is only concerned with the visual appearance of the document. And then we'll take it a step further, combine everything to go to level A conformance, and the A is commonly referred to as accessible document. So then we have a document that is suited for archiving, but is also accessible. So let's get started with the regular PDF creation. So throughout the presentation, I will use small iText code snippets to illustrate how things are done. Of course, some parts of the code are hidden or simplified just for presentational purposes. All the code samples, we have code samples in full for anyone interested in reproducing these examples. So in iText code, we first to create a simple PDF document, we construct a document instance. Then we use a PDF writer instance. So that's the class responsible for actually writing out the document you have created into PDF format. And in this case, we are writing to a file on disk, so the simple PDF.pdf file. We're setting the PDF version to 1.7. So as you've heard yesterday, everyone is very busy in finalizing the PDF 2.0 standard, but until it's finalized, I'm sure it will be finalized pretty soon. But until then, we'll have to use PDF version 1.7. Then we open the document, and we're ready to start adding content. I will use this same example throughout the presentation, adding features to it. So in blue, italic, you see a paragraph. So we're creating a paragraph and adding content to it. Natural content is partly text, partly images. So we have a chunk of text which more or less maps to spans. We have the quick brown, then we have an image of a fox, jumps over the lazy, and then an image of a dog. We add all this content, so this paragraph is added to the document. The document is closed, which tells iText to wrap everything up, flush it to disk, and write the file we have passed to the PDF writer. And I hope it's not a surprise to anyone that the end result would look somewhat like this. So we have the text, the image, the text again, and another image. So that's our simple PDF example that will run as an example throughout this presentation. Of course, as already mentioned in some of the talks about PDFA and in the keynote, this simple PDF document, there are some problems with it if you're concerned with anything else than just visual representation. From original design, PDF was intended as an end product. It had to be portable. The visualization, the rendering needed to be the same on every device, and it was designed to do just that. Now, often people will want to use PDF to get data from it. A lot of data is contained in PDF, and getting data from such a simplistic regular PDF is very problematic. And this data extraction could be used for assistive technology, for screen readers, but also for search for indexation for search engines, full text search. And if we look at this example, it's pretty simple to get the content from it. But if you consider tabular data, a table, without any structure in the PDF, then it becomes already a lot more difficult, because you'd have to detect the text at absolute positions in some kind of rectangular structure with some lines between it, and it's difficult to actually get the proper table structure out of it. And even in this example, you won't be able to properly extract the images. Well, you can get the images, but you don't know what the images are about. So that's a problem working with this simple PDF file. So we'll go to tagged PDF. And of course, tagged PDF is a lot more. I think Olaf mentioned yesterday that it's 37 pages in the current specification. But the most visible result of tagging is that you add structure, you add a structure tree, and you define some kind of semantic meaning to the parts of the PDF document. So we're adding tagging, tags, and structure in this PDF. In our iText example, we add this one line telling the PDF writer to tag our document. And we can do this in such a simple way because iText is capable of inferring a lot of information from the high-level building blocks that we're using. So if we are using high-level building blocks in iText like paragraphs, like tables, like list items, then iText already has a lot of information about these items. It also knows by order in the iText code in which order you are adding these high-level these high-level elements. You know what the logical reading order of the content is. So we have all this information, but when creating a non-tagged PDF, all this information is thrown out when creating the PDF, and we just add the visual stuff. So if we add this one line, we collect all that information and write it out as tagged PDF. Of course, this only works in an automated way if you only use the high-level API of iText. If you start tinkering at the low level, if you start adding content at absolute positioning with absolute positions, then of course you mess up the logical reading order, and you'll have to fix the structure tree, for example, yourself. Then it will no longer be the high-level automated way we are showing here. Also important, all elements that are added in this way are considered content, real content by iText. If you want to mark something as an artifact, so not part of the real content, but for example, a page number or a header could be marked as an artifact. You'll have to do so yourself, of course, because iText cannot know if something is part of the content or you don't consider it part of the content. That's up to the author to decide. So the result of this part of code is now, if we show the structure tree this is in Acrobat, you can see that we have a document with a P paragraph. Then there's a span of text which maps to the chunk we've added. There are two images and a part of text in between that. So now we have added some semantic meaning to this content. It becomes a lot easier to extract data from this document. And also we have defined the logical reading order, which is basically left to right in this one sentence PDF. Now, tagged PDF is more of a, let's say, technical specification. If we want to get actual accessible documents, we'd have to go to PDF UA, which builds on top of tagged PDF. And we'll do this. Well, there are a lot of more requirements for PDF UA, but we'll highlight 3 things. And we'll start with the metadata part. So what are our goals in adding metadata? We have to provide some information about the documents to make it easier for people using the documents, and also make it easier for software trying to assist people with visual impairments, for example, to be able to understand what the document is about. So we have to define what the title of the document is, who the author is, add some keywords about the content. We also have to add which language the document is written in. Of course, if a screen reader has to read out loud a document, it's a lot easier for this technology if it knows what language it needs to read the text in. If a screen reader intended for English language needs to read a German document with some kind of English accent, then it won't be very accessible. So if we just add this metadata to this document, it will make it easier for the software to process this. And we also mark this document as a PDF UA document, so that a PDF reader opening this document will know what kind of document it is dealing with. So in our example, we set a flag saying that the PDF reader has to display the document title. We add that title, so we're just saying this is an English pangram. Pangram is a sentence containing every letter of the alphabet, which is the quick brown fox example. And we say this document is in US English. Then we tell iText to create XMP metadata from all this information we have added. If you look at the document properties of the resulting document, you can see that the title is now English pangram. Acrobat or reader. Acrobat is showing it in the heading of the window, showing the document title. And we have identified the document, as you can see in the XMP metadata, as a PDF UA document. Okay, so now the PDF viewer knows how to deal with this document, treating it as PDF UA. Another requirement we have to deal with is we have to make this document independent of the fonts that are available on the system, and also independent of the font selection strategy of the software opening this document. So a few words about fonts in PDF. It's valid. It's perfectly valid for a PDF to just refer to a font by name. So it can say this part of this piece of text has to be displayed in this font, and it will just have a font name. But it's of course not guaranteed that this font will be available on the system where you're viewing this document. So in that case, the PDF viewer will have to search for some kind of suitable replacement font. But of course, it will not necessarily be exactly the same font. So your document may look differently depending on the font selection. So to make this document fully portable in terms of fonts, you can just embed the font that you're using in the document so that you're sure whatever viewer is opening this document will be able to use the exact font that you were using at time of creation. So in our code sample, when we are constructing the paragraph, we're now actually setting a font. We're using some kind of free sans serif font file, and we tell iText to embed this font. The result, when looking at the document properties, before we had a Helvetica font, which is the default font in iText if you don't set anything explicitly. But you can see that the actual font used when viewing this file was ILMT. So it didn't use the font I told to be used at time of creation. At the right, you can see the result afterwards when we have embedded the free sans font. It has embedded a subset of the font, and you're sure this font will be used when viewing this file. Of course, in this case, you don't see a lot of difference. So I've added a more explicit difference. The file on the right is actually created in the same way without font embedding as the file on the left, with a Walt Disney font. So in the case on the right, the viewer had to find some replacement font because the Walt Disney font was not available on the system, and the end result is a very plain looking text. While if you embed the Walt Disney font, you will get the fancy letters you see on the left. So that's the need and the end result of font embedding. We also have two images in our example, and of course, for a blind user, for example, it's very difficult to deal with visual content in terms of images. So to make this document accessible, we have to provide some alternate text for these images, so that assistive technology can use that alternate content instead of the visual image content. So when adding our image to our paragraph, we can just set an alt text, and for the first image we'll set alt text of font. Looking at the tagging again, you can now see that the first image has an alt text saying Fox, and if you would let Acrobat or Adobe Reader, if you let it read this file out loud, it will now really say the quick brown fox jumps over the lazy dog, while before it would say the quick brown jumps over the lazy, and just skip the images because it cannot read out loud images, of course. If we run this resulting file through the pack tool, the PDF accessibility checker by XY Media, it passes all the checks, but of course it says at the bottom this PDF is technically accessible, because obviously not all accessibility requirements can be checked automatically. A simple example, we can't detect automatically if alt text for images is valid, makes any sense. You could just add placeholder text, and from technical point of view, the image has an alt text. But if you would just say placeholder instead of Fox, then it doesn't make any sense, and the document obviously isn't really accessible. So a lot still depends on the author. As you've seen in previous talks today and yesterday, a lot of these tools and conversion tools often have a manual, a touch-up tool or something, a manual intervention. But iText as a software library, we don't have this interactive feature with the end user, so it's all automated it's all batch processing automation. So we can only deal with the stuff that we can check at the time of PDF creation. So now that we have a PDF UA file, let's take a step back and start from the regular PDF file again to build a PDF A3 B file, so a file suitable for archiving, but only from a visual point of view. So PDFA3, well, PDFA in general is concerned with long-term preservation. So if you have a PDF file today, in a lot of cases you want to ensure that when technology changes, when hardware, software changes, and we're talking 20, 30, 50, 100 years from now, you still want to use and access your PDFs, still be able to access your data, all the data that is in PDF documents. So PDFA as a specification imposes mostly restrictions on how to use PDF to ensure that documents will still be usable in the far future. And basically, you'll have to make sure that your documents are self-contained. You don't want references to outside resources because you have no guarantee that those resources will be available in the future. So everything that the document needs to be rendered, to be used, will have to be inside of the PDF. So document creation is very similar to our first example with the regular simple PDF file. But now we're using a PDFA writer instance, which is our this variation on PDF writer, but this one is concerned with writing PDFA files. And we can set a conformance level. In this case, we want to have PDFA 3B, which will allow iText to do a lot of checks on the document creation to have some kind of assurance that the document you are creating is actually PDFA 3B compliant. Again, there are some requirements on metadata. Most important, we have to identify that this file, we have to add some marker that this file is PDFA file to help the software that is opening the file identify this as PDFA. For example, if you open a PDFA file in Reader or Acrobat, it will add this blue bar at the top. It will say, I don't want to do modification on this file because it's an end file intended for archiving. So we get this warning about it being a PDFA file. The code to do this is very similar to the metadata code I showed earlier for PDF UA, so I won't repeat this code sample. I just want to show you, in this case, we are creating XMP metadata saying we have a PDFA 3 level B file, so that's contained in the metadata in this file. Again, because the file needs to be self-contained, we have to deal with font embedding. So this is exactly the same as for our PDF UA implementation. Then the next step, if we're dealing with colors and you're thinking in the long term and you're using device-dependent colors, if devices change, obviously your color representation will change. So you have no guarantee that the colors in your document will look the same when looking at the file in the future. So we have to make colors device independent. And this can be done using an ICC profile, where there will be some kind of mapping from device-dependent colors to device-independent colors. Your output device will also have a color profile, and you can do the mapping and get device-independent independent colors. We are using a standard RGB ICC profile here, and setting the output intents of the PDF A document to use this color profile. Looking at the content of the catalog, the root catalog of the PDF file that's created, you can now see that this output intent is added as expected. So this file now is able to be rendered device independently from a color point of view. If we validate this file using the pre-fly tool in Acrobat, it will say it passes PDFA 3B validation. We've heard earlier that PDFA validation, well, results can vary, but for this pretty simple file, let's trust pre-flight on this, and let's say we've created a valid PDFA 3B file. Okay, if we put all this together, well, for people knowing the specifications, it may seem a bit odd to combine these things this way to get a PDFA 3 level A file, because we're actually doing a bit more than strictly necessary in iText in this case. But in general, going to the accessible conformance level for PDFA 3, we have to add some more accessibility features. So we're using our PDF UA implementation on top of PDFA 3 basic level to add this accessibility. So again, we're using a PDFA writer. Now we're setting the conformance level to level A, obviously. And doing the same check as before, but now for level A, the pre-flight tool tells us we've created a valid PDFA 3A file, which will now contain the document structure, the logical reading order, and all the tagging as expected. So I've now shown you how this all works in terms of iText code. Do you have some kind of certainty that what you're creating with iText is compliant with the specification? Well, we will do a lot of checks from technical point of view, as I've told you, based on the conformance level that you've set in the PDFA writer. And whenever we find something that is not according to the specification in terms of requirements or restrictions, we will throw an exception so that you will not be creating in an automated way in a batch processing, you will not be creating files that are not according to spec without you knowing. So you don't run into the risk of creating files for your archive years and years on end, and then finding out afterwards that what you were creating was not actually an archivable file. But of course, as said, and especially when dealing with accessible files with PDF UA, we can't check everything automatically. A lot depends on the author. And it will be the author's responsibility in this case. Obviously, it will be the developer's responsibility to make sure that every aspect of accessibility is met when creating these files with iText. An example for something we cannot check in PDFA, if we talk about logical reading order, we can assume that the order in which you add the content in the file is the logical reading order. But if you start mixing up things or adding content in between, we cannot guarantee that what you have created as logical reading order is actually the real order in which you have to read the file. So that's something that is not possible from a technical point of view. For accessibility, as I gave the example before, we cannot check properly. We cannot check if an image has proper alt text descriptions, for example. So that's still on the responsibility of the author creating the document. So, for example, this is output from iText when creating a PDFA file. I did not embed the font for a part of text, and it will throw an exception saying you have to embed all fonts if you want to have a proper PDFA file, and you didn't embed this font. So then you know where to fix your code to get valid output. All right, so that was the technology in iText supporting all this. I now want to show you two use cases using this technology. First, probably very well important for the German market is the ZUGFeRD standard to create electronic invoices, which are based on PDFA 3. And then after that, to conclude this presentation, I want to show you how you can flatten dynamic forms in PDF, XFA forms, and still retain their accessibility support. So starting with the ZUGFeRD invoices first. So PDF A3 is the base level for ZUGFeRD. So we're starting with the PDF A3B technology. We have to add proper XMP metadata identifying this file as ZUGFeRD compliant. And we have to attach the invoice, the electronic invoice, as an XML attachment to this PDF to make it a valid ZUGFeRD file. So obviously we can simply start from a PDF A writer, and we tell the PDF A writer you have to conform to ZUGFeRD. Telling the PDF A writer to follow this conformance level will allow it to create some metadata automatically without you having to tinker with all this stuff. So we create XMP metadata, and we have to define what the name of the invoice attachment is in this ZUGFeRD file. So we just use invoice.xml in this case. So going from our regular PDF file, PDF A3B, we still have to add this file attachment. And we make one simple call to iText to the PDF A writer, saying I have a ZUGFeRD invoice, which is just the description text of the file attachment. We tell it where on disk it can find this file. Tell it how to store, with which file name to store it in the PDF document as an attachment, and define the MIME type, the type of document it is, which is an XML document in this case. And in PDF A3, a file can embed it as an associated file. So we have to define the relationship this file has to the document, because it's a document level attachment, and it's an alternative representation of this document in this case. So you have the, let's say, rendered visualization of the invoice, which is in the PDF content, and then you have the XML structure defining or also containing all the data about the invoice. If we take a look at this file, you will see the file we have created with this code. It's a PDF A file, and you can see it has an invoice attachment, and it's described as a ZUGFeRD invoice. So in iText we have implemented this to do this from PDF point of view. What we don't do is check if the invoice XML itself is valid, for example. So there are requirements on how to structure this XML file in ZUGFeRD, which is part of the standard. This is not something, these checks aren't done in iText at the moment. We do have a user, an open source user. It's listed in the booklet that is in front of you, that has built a ZUGFeRD application on top of iText, doing for example these checks on the actual content in the invoice XML. Then the second use case is concerned with XFA forms. So for people not knowing XFA forms, I'll give a very brief introduction. It's one of the two types of forms available in PDF, and XFA forms are very dynamic in nature. They can change based on user interaction, but also based on data entry. So for example, if you have a form field asking you how many children do you have, and you enter 2, then for example 2 fields can appear to enter the names of your children. If you enter 3 fields will appear, and so on. So the form can change dynamically, will be re-rendered and reflowed depending on user interaction and data entry. Often after using these forms, you will want to have some kind of end result, for example, to store in your archive. And at that time, often you don't want the interactivity anymore. You just want to have let's say, a static copy, like a printed result of the form. And this process we call flattening, to remove all interactivity, all the dynamic nature, and just have a static regular PDF file. In our first implementation of flattening XFA forms, we just produced regular PDF without any structure information, without any tagging, without any accessibility. So like in our very first example, all extra information was thrown away when creating the PDF file. But of course, since XFA, it's based on XML, so the complete form is described as an XML structure. And this XML structure, it contains a lot of information about extra information about accessibility, but also the logical reading order and how the document is structured hierarchically. So we can use that information when flattening the file to produce an end result, a PDF file that still contains all this structure information. So if you create in Lifecycle Designer an XFA form, simple form, doesn't even have any fields in this case, just static text and images like the example we used before. Then let's add some accessibility information. So the first part of text is marked as a level 1 heading, so an H1 in terms of HTML. And the Fox image, I've defined an alternate text for this Fox image, just saying Fox like in the tagged PDF example. And this sort of information is all stored in the XFA form. If we run this to our flattening process, you can now see that the resulting PDF will contain this information from the XFA form, and it will mark the first part of text as an H1 heading. And if you look at the properties of the figure tag representing the Fox, you can see that the alternate text for the image says now it now says Fox. So at this point in our XFA worker flattening implementation, we retain all this extra information that is available in XFA forms. So with this example, I will end this presentation, and if there are any questions, I will do my best to answer them. Thank you.